everyone, and welcome to our first virtual Corteva Seed Grower Combine Clinic. My name is Stacey Rampton, and I'm the seed production agronomist in Manitoba. I think I know most of you guys on the call, but I wasn't sure how many folks from Wahpeton, North Dakota, and Ontario would be calling in. But I'll be kind of your moderator for this morning's meeting. We're trying to kind of come up with a bit of a different opportunity to try and improve some quality produced this year. So we thought we'd do something slightly different, getting us a little bit closer to harvest and have a really informal interactive harvest clinic as close to harvest as we could without impacting you guys in the field. So today's topic of discussion will be pretty specific to optimizing combine settings on case models specifically and offer some insightful storage considerations. So I can only speak for Manitoba, but I think in general, late planting was something that many of the folks on the call dealt with this spring. And knowing this now, I wanted to get ahead of likely having a late harvest. And typically in Manitoba, a late harvest for us would mean we're combining higher moisture grain in low or declining temperatures under some wetter cutting conditions. So the experts on the call this morning are going to lead you through some ways to fine tune some concave fan sieve settings for your seed, soybeans specifically, and how to adapt for any changing conditions throughout the day. Achieve top quality soybean seed production, specifically from both an appearance and integrity standpoint. There's a lot of quality factors that we can control at harvest, so even improve once we've got that product in the bin. So if we're prepared on how to handle any inevitable challenges that we're probably going to encounter this fall, I think we should probably improve our overall seed quality. So with that, to start us off this morning, I'd like to introduce you to the combine expert himself, Brent Priel. Brent grew up on a farm near Vanscoy, Saskatchewan, with his farming parents, and has been working with Case IH and New Holland equipment for 34 years in West Central Saskatchewan area. I didn't know that you were an expert in New Holland too, but that's so awesome. He's got vast amount of experience in every field. More recently, he was a trainer for a dealership and taught technicians how to diagnose, fix, repair combines for 10 years in Canada and the US. So from May till August of this year, he was a Case territory sales manager covering on mat leave and is now working for Case New Holland International as a precision technology support specialist. So I'm gonna say this is a pretty informal presentation this morning. I don't think Brent has anything that he really wanted to share on his screen, but we're gonna go through some settings and different things like that. And if you guys have questions, you've muted yourselves, you can unmute yourself and ask a question throughout this presentation. So with that, I'll pass it over to Brent.
Good morning, everyone. I don't have any presentation to actually share with you. I thought it would be more of a question and answer thing, but typically when I was teaching the class to dealership technicians from the Case IH side, we had two classes. One of them was actually the introduction to the combine itself, which is where we introduced you to the combine, the different models, horsepower, and things like that. And then we got into, which is what I think would be pertinent to this call, would be you're now a piece of crop standing in the field. And then we would run you through the combine, going through the header first, and then through the feeder house, up through the rotors, where we would go through the threshing first, then into the separation. From there, the grain falls down into the bottom of the grain pan, where we go through cleaning, and eventually out through the back through the residue. From there, also the grain would come up into the grain tank and out the unloading auger. And we typically spent about 4 days on that. And how long do we have to do this meeting, Stacey?
I gave you about 20 minutes for a presentation or kind of walk us through something, and then 10 minutes for questions, but half an hour is great.
Okay. Mm-hmm. So for us to cram 4 days worth of stuff into 30 minutes is going to be rather difficult to do.
Only you will be able to do that.
We'll see what we can do, and then get your question and answers done too. So basically, as we're as you pull up into the field with your combine, there's a couple of things that, first off, I like to take and go through exactly what we do when we figure out if the field is even ready to combine, right? We'll go out to the field, we'll take a sample of grain, we'll pull it off of the heads with our hands, and we'll take and rub that material together. And then as we do that, that simulates what the combine does, right? So we take in the pressure that we put on our hands as we take and push things together to rub. That's actually like our concave setting. When we actually take and move our hand, that's going to be like the rotor spinning. And then after that, we take and separate our hands and we let the air blow the chaff and residue away, and we see what seed we've got in our hand. That's what our fan, their cleaning system, is going to do, right? And then from there, we test the grain to see if it's got the right moisture and stuff like that. So all of that is crammed into this big machine, and that's what helps us get our productivity done. So some of the things that a lot of people are not, or I find anyhow, in the classes that come through, when I ask the students what is the most important part of grain loss on a combine, a lot of students don't have the right answer. A lot of them seem to think that it has to be with the settings of the combine. But
I want the 5 points or whatever.
What's that? Sorry.
Maybe just some background noise.
Maybe. Anyhow, as we go through the combine, when they think it's the settings of the combine that has the most effect on loss, and then once we go through a discussion about things, it's actually the header that gives us the most amount of loss on a combine. So if you're doing anything where you're doing swathing or windrowing, and then you run it through the combine after, that header loss becomes twofold because we run it through 2 headers, one of the windrower and then the one on the combine. So it's very, very important that we have our header in good shape, our knife, our guards. Also, if on the draper, if you're using a draper, that we take and have a something so that the seed doesn't fall off or roll off the front of the draper before it goes in through the combine. And then from there, as the operator is once the header's in good condition, as the operator is running through the field, we need to make sure that, you know, the reels are not going too fast. If you are combining and you've got the radio off, which a lot of young people don't like to do, they seem to have the radio blaring, you listen to what the combine is doing. So listen to any kind of seed that might be hitting the windshield. If there's any seeds that are hitting the windshield, that's seed loss. It's stuff that's not going through the combine. So you will see things, for people that do pay attention, they might have some kind of a barrier between the header and the windshield, and that's basically to keep that seed from bouncing out of the header, but keep it in the header. Then once we get from the header, we move up through the feeder house, and the feeder house is there to transport the material from the header up into the beginning of the rotor, where we have a cone. So the feeder house, we need to have it set so that it's the header is positioned in a way that the grain goes through or transitions from the header into the feeder, keeping the distance as between the feeder chain and the header as minimal as possible, which might mean extending the chain of the feeder house to push the drum forward. By pushing the drum forward, as material flows off of the header, that chain then grabs the material and pulls it through the feeder in a very efficient manner. The next thing we need to do is we need to make sure that the chain is positioned properly on the floor. So on the older combines, we could reposition the floor. There were 2 different spots for them. And I see there's a 9120 tucked up there behind you, one of you guys. So, and if you're looking at the floor on the bottom, there is 2 holes that we can put those in. One typically is the floor is in the lower position, and that's for high crops or lots of material that's going to flow through there. If we've got a crop like you guys had last year, Manitoba was pretty droughtish and there wasn't a lot of crop. It was rather thin. You might have to take and move that floor upwards so that the feeder chain grabs that crop as it pulls it through the feeder and up into the transition cone. Okay, from there we get up into the transition cone, and the idea of the transition cone is to increase the speed as it goes from the ground speed of the combine to the rotor speed. So the crop actually gets increased in speed as it flows through there before it flows into the rotor itself. When we get up into the rotor, now we have the concave area, which is where the threshing happens. 100% of the threshing happens in that concave area. Now it's important for you to start to remember some of these notes because it's kind of like a puzzle, and we put the puzzle together at the end and it'll start to make sense. But we have 100% of the threshing that happens in the rotor concave area, and we have about 80 to 90% of the separating that happens in that area as well. Okay, now from the threshing concave area, we move into the separating area. Again, we've got some different modules in the back there than we have at the front. Depending on what crop you have, if it's an easy to thresh crop, you might put some large skip wires in the front modules, and we don't want to break the straw up too much as it flows through that rotor area. If we break it up too much, it flows through the concaves or the modules and then down on top of the sieve, and then when it's on top of the sieve, we can overload the sieve, and that could cause problems too. Now, I'll talk about that when I get a little bit closer to that, okay? About overloading the sieve. Any questions so far from you guys? Am I following kind of what you're looking for? Okay. So from the back of the separating area, we then go through the beater. Case still makes a beater for at the back there, but they also put a chopper in there. So most of the combines that come into Canada have a chopper in it. Very few of them have a beater. But we can put on, and there's a grate underneath of that chopper that we can put a cover on. And if we have overloading of the sieve, it's a good idea to put that cover in. Once the cover is installed underneath the rear chopper and above that grate, then a lot of the times it does not come out unless when you do kill stalls, you find that you could use that last little bit of separation. So from there, the grain drops down into the grain pan. Now, does everyone here have what I call a flagship combine? The flagship combine will have the CVT drive that runs the rotor, whereas a mid-range rotor combine has the belt. So mid-range would be like the 1400 up to the 2588s. We still make that combine today. Now it would be the 150 series, whereas the new combine, the flagship, is a 250. So what does everyone have here? I see that Buffley Farms, you've got the flagship combine. Kind of quiet from you. Yeah, I like usually to get some interaction going because you know what? You learn from each other that way as well. So don't be afraid to speak up, guys. Okay. Well, with no replies, I'm going to assume that everyone has a flagship combine. Okay. So from there, as the grain drops down into the bottom side, where we do the cleaning, the first part that we have underneath of the concave area is going to be a grain pan. And the grain pan, it oscillates back and forth and an up and down motion. Okay. And when it does that, it stratifies the grain and mog, or material other than grain, so that as it comes to the back of the grain pan, there's a blast of air from the fan and some fingers that hold the crop up so that as that blast of air comes through those fingers, everything goes airborne. Okay, and a lot of people seem to think that material that flows over the sieves is kind of like what you'd find in a straw walker machine, conventional machine, that it kind of flows along the top of the sieves, when really it's all airborne and above the sieves. We need to have enough air blast to bring it up off of the sieves. If we don't have enough, it sits on the sieves, and that creates problems. Okay, and that's where I was talking a little bit about overloading the sieves. We have too much material that flows down over top of it or through the concave and separating area and down on the sieves. Then you need a lot more air to get that material up and airborne. If it's too high off of the sieves, then what happens is the grain gets blown out the back. So we need to have the whole cloud of mog, chaff, grain low enough that as it flows through the back and that sieve tickles the bottom of the cloud, the grain that's already separated or partially separated then falls through the sieves and down up into the grain tank. If it's too high, then it doesn't get a touch to tickle that cloud and the grain goes out the back, which is not good. If it's too low, then it gives us problems on the sieve where we can't separate it. So that's what the grain pan, it can stratifies the grain. The heavy stuff comes to the bottom, whereas the lighter stuff flows to the top. And then as it comes through there and that blast of air comes through, then the grain that's already threshed drops right through the pre-sieve. And a lot of people don't understand where we need to set the pre-sieve, but the pre-sieve should be set to a height that you take and close it, put your grain that you're harvesting on top of it, and open it up just enough that the grain you're harvesting goes through it. So if you're doing something like canola, it's going to be a lot closed, maybe 1/8 of an inch, as opposed to something like corn or soybeans or things like that, where it's going to be open a lot more. And the whole idea with that is the threshed grain that comes through there falls directly through the pre-sieve down onto another grain pan down below, which is slightly above the lower sieve, and then it then would flow out the back, whereas the clean grain would drop right down into the clean grain cross auger and flow up inside the grain tank. Okay. From there, as the air blast of air flows through or keeps the material up above the upper sieve, then if we take and have the pre-sieve open too much, what happens is the grain and chaff and other mog will flow right through into that clean grain, and we'll end up with a dirty sample up inside the grain tank. Or it's possible on our combines that we can overload that clean grain cross auger and possibly get some material in the fan and cause that fan to plug up. So then as it flows, the material flows over the upper sieve, then the remaining stuff goes through the upper and lower sieve, and then down in the and the tri-sweep processor has actually got 3 impellers on it. There's the one on the bottom, there's one in the middle, and one at the top. And each of those impellers travels at a slightly different speed. You can tell that from the size of the pulley. And as they travel at a slightly different speed, the grain from the bottom impeller gets thrown up into the middle one, which is traveling faster or slower than the bottom one. And then that's where we get grain on grain threshing. From there, it moves to the top one, where again, it's at a different speed, more grain on grain threshing. And then from there, it gets thrown onto the back of the grain pan, where it goes through the separation area again. And then from there, we get it, the clean grain goes up the clean grain elevator and up into the grain tank. And from there out the unloading auger. So that's kind of how the combine is supposed to function. Any questions so far on what I've covered? No? Brian, you're kind of quiet there. Neil?
I guess I have a couple things. I guess this year, like in Manitoba specifically, like we have fairly large plant biomass. We're going to be probably going into a scenario where we have higher moisture beans. I guess one thing we've struggled with in the past when we hit scenarios like this is setting the combine aggressive enough to thresh out pods, but not crush or split the seed. So specific to like seed production, do you have any like good suggestions for us to like try and fine tune that at all to avoid that happening?
No, I haven't done most other crops. So I'm going to guess that typically soybean is easier to thresh crop. The pods, they pretty much thresh as they coming up through the feeder house, or do they need to get into the rotor area before they thresh? Geez, you guys are a tough crowd, I'm telling you. Okay, well, one of the things that we can do on our combines, if we've got something that's hard to thresh, we can change the concaves, everything from, we've got some large wires all the way down to a really small wire, okay? So if we figure out, now let me see if I can find, as I'm talking here.
Actually, that was kind of my next question. I feel like you're going to answer it, but I was going to ask you what your take is on round bar concaves and if we should be fitting that in all of our models, or what do you think?
Yes. Just give me a second here. Let's see if I can find this.
Got a couple of questions that came into the chat box too, Brent. Is it okay if I read them out to you while you're looking for that?
Please, yes.
Okay. Leslie has asked, what is the ideal module setup?
Okay. And that, I'm just looking to see where I've got my, you know what, I'm just going to go into a different book here.
Okay. Not to rush you. You do have about 7 minutes left.
Okay.
And then Leslie's also asked, like, what about slotted holes? And Joe asked, can you talk about concave orientation and vein?
Yeah. Here's what I was looking for.
You could probably all wrap that up into one.
Yes. I found what I'm looking for. I just need to threshing. And then I'm going to share my screen here.
Perfect.
Because this is going to show us some of the different concaves and and share screen, and I want this one. So when we start talking about the rotor, as material comes into the rotor, there's different things that we can do on the rotor to change the crop flow through the combine. So do you guys know the difference between a large tube and a small tube rotor? The outside diameter of both rotors from the tip of the rasp bar to the tip of the rasp bar is the same. However, the tube itself that the rasp bars are bolted to is different. And depending on which rotor you have, you need to treat the crop differently as it flows through the combine. Okay? Can you see this?
Yeah.
Okay, so you'll see on the front portion, of this, we've got an angle here, and how that angle is slightly different than the angle up here. So just like an auger, or just like a drill bit, the angle of the front of the rasp bar is going to change how quickly the crop flows through the combine. Okay, so keep that in mind. Also, as we move into a standard rotor, we've got some rotor elements here. We've got a straight bar right here, and here is what is called a helical bar. Those also change the material, how it flows through the rotor area. So if I move from that over to here, and I'll zoom in a little bit, drag this down, you can see on the back of this rotor, which is the standard rotor, the small tube rotor doesn't have these bars per se, they have them just on the rasp bars. But you can see as material would flow through, I think it's this button here. As material flows through the rotor area with these flat bars, as opposed to a couple sets of helicals, like what we'll show here in the bottom, down here, the material is going to flow a lot faster through here than it will in the top one. Does that make sense? So when we start talking about cracked seed is typically because the concaves are too close to the rotor, or the material is bouncing around in there too fast. And if we can kick the material out the back faster, that means it spends less time in the threshing or separating area and possibly less prone to damage. One of the other things that a lot of people do with a rotary combine is, because material can wrap around the rotor about 2.5 to 3 times in the concave section and about another 2.5 to 3 times in the separating section, we get a lot more crop drag, dragging that rotor speed down. And we need to have a lot more horsepower on a rotary combine to keep it going, especially when the crop starts to get tough. And that's one of the other things you mentioned, Stacy. So as things are tough, we need to take and increase the speed of the rotor. I would increase the speed of the rotor till you start to see some cracking of your seed in the grain tank, and then back it off about 30 RPM until that cracking goes away. And then as the material starts to get tougher in the evening, you can go a little bit longer, again, by checking that, increasing the rotor speed, dropping it back down until there's no crack, and then you can get some longer periods of harvesting done throughout the season. Okay, now your question about the concaves. So here we've got the degrees of wrap. On the 1400 series, we had 136 degrees of wrap. When we go from the 1600 to the brand new combines right now, this hasn't been updated in a bit, but if we were to go buy a 7150, and I know there's some of those out there, there's a lot of those in Southern Ontario, a 7140 or a 7130. That one series designates that it's the mid-range combine. Okay, they all have the same or similar, they have the same wrap, but the concaves on the newer ones are half the width, which means they have double the concaves. So you can still take and put the new concaves from the brand new combines into an old 1688 if you want. There's an adapter you can throw in there. Or when we get into the flagship combines, we have 180 degrees of wrap. So as we move from those into the concaves themselves, now here we have, there's a left and a right concave on them. Make sure that we get them in the right side. And here we have a slotted grate. Let me get that a little bigger here. try and position that so everyone can see them. So if we take a look over here at the slotted grate, and if we look over here at the large wire, right? Or if we come and look down here at the round. Well, I want to go around here. If you were to take your hand and quickly rub it back and forth on any one of those on the inside where the grain rubs, you'll find that on the large wire, it's going to be a lot harsher on your hand than it will be on the slotted grate. Okay, we also have a small wire right here. And if we look at, again, at the small wire, there's a lot more bars that go across here, which again makes it a lot harder on the crop as we flow through there. So when you ask about which grates to put in there, the ideal one, if we look at the operator's manual, it gives you a guide to start with. But remember that that's only a guide and that you can change those to what you feel you need, depending on what you see when you do a kill stall. Does that make sense? Does everyone do a kill stall?
I wondered if you would bring up kill stalls in this meeting.
Yeah, it makes me
terrifying.
So a lot of people seem to think that it's too hard on the combine to do a kill stall, or they don't have the time. I'll tell you, it's very, very important that you do a kill stall, because that gives you a time frame slot of what's going on within the combine. You need to know what's going on inside the combine in order for you to set it properly. So typically, to do a kill stall in a really shortened up version, we would take and run the combine in that 90 to 100% range of engine load. And on the new combines in the procedures tab, there's a button that you click and it shuts the combine down. It shuts the engine off. On the old combines, pardon me, prior to this year, that's a software change they did, you were supposed to take and pull back the throttle, and at the same time that you pulled back the throttle, now you had to push on the brake to try to stop the combine, and also push the hydro lever forward so that you were overloading the engine and the engine would stall. But with our large engines, that seems to just get them upset and they want to take and carry on. So you're really grunting when you do this. So my suggestion is run that combine in that 90 to 100% engine load, reach behind you, and with everything working the way it's supposed to be, shut off the key. Once everything stops, shut off your thresher and your feeder, take and start your engine, and at this point, let the turbocharger cool down. Play on your phone, do whatever you want. I don't want anybody to get out of your combine until the engine is shut off. Okay, once the cooler turbocharger is cool, then you should be able to reach behind you, shut off the key. Now you exit the combine and you go to the back of the combine, where you now start to check what you see inside. Now, typically you would take and go to the back into the separating area, pardon me, into the cleaning area and look at what's on the sieve. That's what most people do. But the other thing that you need to do is you need to check for results in the rotor area as well. So if we look on the sieve area, what are we looking for? You need to make sure that the crop is evenly spaced left to right, okay? And that there's typically a little bit of area at the front of the sieve and at the rear that is clean because of the fan, that how it blows it. But then once you got that to where you want it, you need to get up into the top, and you should check to see what's in the rotor area, whether you've got seeds that are unthreshed at the back in the separating area, or if they're threshed, but at the very back, they're still in there. Or if we got, for example, let me see here, if I can do this, Control 2, let's go red. If I take and have a rotor, and we take and put on the front portion, the threshing area, we need to have 100% of the threshing happen in the front area, right? In the back, and then we're going to have about 80 to 90% of the separating happen in that area. If we do a kill stall and we find that there's seeds at the back here, that means that we need to make some changes in the way that the crop flows through the combine by changing concaves or rotor elements so that there is no seed at the back. If we have unthreshed grain anywhere back here, even slightly behind the concave, there's no chance of getting that threshed. So that has to be changes done in the rotor area as well, which is why it's so very important to do a kill stall to find out what's actually happening. Now, Stacy, you had mentioned about what would we do if we see some cracked grain. So again, if we do our kill stall and you're looking in the rotor and you get some seeds that come out, and maybe the seeds are, let's go this color, and we've got some seeds that are coming out in this area, in the separating area, and it appears to be cracked, well, then we need to make some changes in the concave area, right? Before it gets back there. By changing concaves, rotor speed, or rotor elements, we can make some changes to see what's going to happen inside the combine.
That's awesome. I like your visual of that. That does, yeah. It actually puts it in really good perspective when you draw it out like that too, to do some diagnosis. And I'm sorry to cut you off, Brent, but we are short on time here, so I'm going to have to switch gears over to our next presenter. But that was really great information. I know you are just a wealth of knowledge and can like talk someone through a combine in your sleep. So if it's possible to like get your contact information. I know there's a lot of growers that are texting and stuff with questions here on the side as well. I'd like to maybe like summarize some of the information you just gave us today and have it on a sheet for us to reference later. That would be awesome.
Yeah, that'd be fine. And you can contact me. You have my contact information, Stacy. So if there's anything else that comes up afterwards, don't be afraid to reach out.
Okay. Oh, I appreciate it. Thanks so much, Brent. If you want to stay on the call, I'm going to pass it over to James, our storage expert, next, but whatever works for your schedule.
Yeah, I can wait.
Okay, sounds good. Well, next on our agenda, as I mentioned, is James Dyck from OMAFRA. I've just coined him as the most knowledgeable storage specialist you'll just ever meet. James is the engineering specialist for crop systems and environment with the Ontario Ministry of Agriculture, Food and Rural Affairs, and he's based in Vineland, Ontario. He was raised on a cash crop and hog farm in the Niagara region and completed his mechanical engineering degree at the University of Waterloo. His work at OMAFRA focuses on best practices, innovations, and environmental impacts of grain drying, storage, precision agriculture, field equipment, and on-farm energy use. And James actually was on our spring meeting this past year and had some really great information for us. I was kind of hoping he could do a quick summary closer to getting into harvest, especially with potential for a wetter harvest in mind. So with that, I'll pass it over to you, James.
Thanks, Stacy. Yeah, for those of you that were able to join the Corteva meeting back in, I think it was late March, some of this may be familiar to you. Trying to recap some of the most important things to consider when you're storing your crop, especially considering we may have a slightly later harvest. I mean, I know in Ontario here we had some wet weather early on in the spring that did delay some planting. And so I know every year I get calls in October, November, December saying, I've still got soybeans in the field. They're still at, 17, 18%. What do I do? So we're going to talk about that. Here's just kind of a quick summary of what we're going to go through, some high level research and maybe some things to keep in mind, and then really some tips that are hopefully going to help you do a better job storing your grain. We'll touch a little bit on harvest, but I mean, Brent did a great job walking us through the considerations in the combine. Obviously, there's lots of stuff you can do in that machine to maintain your grain quality and get it clean. And especially, considering we're not just harvesting grain, but seed, we want to do an extra good job of trying to maintain that. So I guess without further ado, the first thing I want to touch on is harvest timing. This is a question that we get from time to time saying, well, am I better off especially with soybeans. Am I better off harvesting early or waiting late? Like I said, I tend to get calls every year saying, with people that say, you know, my soybeans were 16% at the beginning of October and now it's December and they're 18%. What do I do? So we were looking at this and saying, well, how much does seed quality decrease over time? We did a small study in 2019 just with a few locations around Ontario. And what we found was, bottom line, the moisture, as you can see, varied quite a bit depending on our harvest date. That was really due to the local weather conditions and the climate at the time. But the germination for the seed actually really didn't change much, even for the stuff that we left in the field until the following year. So I think the message that we found here, now this is, this was just a small study, didn't necessarily replicate it many times in lots of different situations, but the germs seem to hold on pretty good. So if you do feel like it's worth waiting to harvest a bit and wait for the soybeans to dry down, the caveat is that that won't necessarily happen, and you can see that the moisture does vary quite a bit. So I think if you're facing grain quality issues, it is important to get it off. And for those of you that think that Southern Ontario is just a summer paradise all the time, we did have a couple of snow events as we were trying to harvest here in mid-November and early December. So we do have to contend with winter weather here as well. But once you do have your crop off the field, whatever condition it comes off in, you're asking yourself, how long can I actually store this grain before it starts to go bad on me? That's really going to depend on the temperature and the moisture condition of that grain. And that's what this chart is telling you, basically the number of days that you can store it at various conditions. Not going to spend a lot of time here. This isn't germination. This is just overall grain quality. But basically the message is, if your crop is really wet, even if you store it very cold, you're not going to be able to keep it for longer than a few weeks. So you really do want to get that grain dried down as much as possible. And then even at a warmer temperature, you can store it for quite a long time. Of course, when we look at storage temperature itself, there's lots of different temperatures you can store at. It's obviously, most of us don't have climate control on our bins other than the fan. And really that fan on your bin, whether it's dry or whether it's a storage bin, that fan is really the one tool that we have to try and maintain that grain in as good condition as it possibly can be. So airflow is key. And that's what we're looking at. But obviously the climate changes. And so, moving from late summer, early fall into winter, we are storing that grain at very different temperatures. This data came from the USDA handbook, many years ago, but I think it's still really good data. And I like that the range of temperatures they have. And what you can see here is that in particular, the impact on germination for very cold storage in winter, there isn't one. In fact, storing grain at cold temperatures will preserve the germ longer. So we don't need to be concerned about freezing our grain down, even if it is a bit wetter. That germination is going to be fine. Of course, as the temperature warms up and as that grain is warmer, it's going to be able to be stored for a much shorter amount of time before that germination does start to drop off. So again, the importance of getting your grain dry and keeping it there. When we're talking about drying itself, often that takes some heat as well, and we'll touch more on that in a minute. But you want to be careful of how much heat you're adding. A typical high temperature dryer that you might use for corn, they run anywhere between 40 and 80 degrees centigrade, or sometimes even more. For the large tower dryers, they'll run as hot as 100 or 110 degrees centigrade. That'll dry grain in a big hurry, but it doesn't do nice things to your germination. So if you're trying to preserve the seed, really what you should be watching for is keeping that grain temperature as low as possible. I'd say 40 degrees is the absolute top end for that, and probably closer to 30 or say 90 degrees Fahrenheit. That's a nice safe number. You should have really strong germination after drying it at that temperature. It is going to take you longer, but with seed, I mean, the risk of losing that germ is pretty important, or we don't want to do that. So watch your drying temperature if you are working in a high temperature dryer. The other thing you need to be careful of is relative humidity. Now I know you're sitting there thinking, well, I don't have a relative humidity dial on my dryer. I can only control the temperature. And that's true. And we'll talk about the relationship between the two. but basically, if you add too much heat to your dryer, you warm the air up too much, you'll dry it out, and you'll get that relative humidity down in the 20 to 30% or even less range. You run the risk of cracking those seeds or even splitting the beans. And then obviously, you know, you don't have a viable seed anymore. So again, this goes hand in hand with keeping that drying temperature low. You'll end up keeping your relative humidity higher. And you want to do that to preserve the integrity of that seed. But when we talk about relative humidity, I'm going to take you back for a minute to your high school science class, and maybe some of you that was further back than it was for me. But if you can recall that air around us has a capacity to hold water, and that capacity is impacted by the temperature. So if you think of air, think of it like a cup, and that cup represents how much water the air can hold. And say we've got air at 0 degrees. I mean, it's not 0 right now, it's a nice warm day. But say 0 degrees, that air has a capacity of, let's say, 1 to hold water. So if we have air at 100% relative humidity, that cup is right full. It can't hold any more water. If we try to use that air to dry grain, in fact, it'll probably end up getting our grain wetter because our air is going to be giving water up to the grain rather than the other way around. So we can't dry with that air, but we can heat up that air. And if we do that, it will actually increase the capacity of that air to hold water. And if we heat it without adding water itself, then our 100% humidity air has become 50%. We heat it up by 10 degrees. Do that again, and you get basically the same impact. So kind of every time you heat the air up by about 10 degrees centigrade, you drop your relative humidity by about 50%. And so now you can see at 20 degrees, that air that wasn't going to do any drying for us at 0 degrees now has a whole lot of free space. And if you blow that 25% relative humidity air through grain, it's going to absorb moisture very readily. It's going to dry that grain out. Now, this has been tabulated for all kinds of different grains. It's called an equilibrium moisture chart. And I know it looks busy, but it's actually fairly simple. So on the left-hand side, you've got the air temperature in degrees, and on the top, you've got the relative humidity of the air. So as an example, I mean, the room that I'm sitting in is probably about 20 degrees centigrade, maybe 25 because it's summertime. Let's say 25 degrees. And it's probably around, say, 60% humidity. It's a bit of a humid day here in Ontario. So at 25 degrees, 60% humidity, if I had soybeans on the table in front of me in this room, those soybeans would eventually equalize with the air and they would reach about 10% moisture. That's probably a little on the dry side, but nevertheless, that's how it works. So if I wanted to adjust the moisture level of those soybeans, I could either cool this room down or heat it up. And if I cooled it down to say 10 degrees, that moisture would creep up. If I added moisture to this room, the moisture would creep up, those sorts of things. So the moisture of your grain is really dependent on the air conditions around it. And what you'll find is that 70% relative humidity is about the sweet spot. And this is true for most grains. This table is specific to soybeans, but you can get tables for corn and wheat and any other grains that you happen to be growing. 70% is roughly the sweet spot. So that's actually a good thing because 70% is fairly, it's on the wetter side. Like our climate is very conducive to achieving 70% relative humidity. Certainly in Southern Ontario, you know, that's not a big ask to get air that's dry as 70%. And probably out west, you're even drier than that many times. So you shouldn't have an issue getting your grain dry just with using natural air. And so this, I mean, the message here is that you can certainly just use a bin fan to dry it down. There are some other considerations, but basically this chart will tell you kind of the moisture level you'll be able to hit if you are just using a bin fan. Of course, the table's complicated and maybe you don't have it handy or you don't always remember to look it up. Well, there's an online tool you can use. It's called BinCast. It's available at decisionfarm.ca. I have checked. You can use Manitoba locations. I'm not sure about the United States. Weather Innovations is an Ontario-based company, this system basically pulls data from localized weather stations around you or around whatever location you choose. It'll give you a forecast over the next week for every hour It'll tell you the temperature and the relative humidity that's expected in your area. And then it will predict, depending the grain you choose, it'll predict the moisture level of your grain if you were to aerate it at that time. So this is a really helpful tool. You can use it for planning out your next, say, week or so of either grain drying or aeration. You can take a look at this and say, is it going to be a good week or not? They even color code it so you can see the green zones tend to be drier, the yellow zones tend to be wetter. On this particular day, you can see that it went very quickly from a good drying day to a bad one as the humidity changed and as the temperature dropped. So I think this is a great tool just to help you be a bit more aware of what's going on with your weather and plan out what you can do in your bin. Because as I mentioned, airflow is the tool that we have to control the moisture in our grain once it's in storage. And depending on how much airflow you have and how much heat you're willing to add, there's different things we can do with it. You can use a high temperature dryer, and you probably will need to do that if your grain is very wet. Those typically have high airflow. They'll dry it in a couple of hours, but you do have to be careful of over drying and of grain damage because you don't want it to be too hot. Natural air drying is basically putting it in a bin with a decently large fan on it, probably not too deep, maybe 10 to 12 feet of grain, and it will take you a few days or even a couple of weeks to dry that grain down depending on the climate. But you're running a low risk of over drying, especially if you can keep that relative humidity where you want it. And it is very gentle on the grain. Of course, if your grain comes off the field mostly dry, you don't really have to worry about drying it. You can just put it in a bin with even a small fan on it. Just run that fan to kind of maintain the grain and equalize it. And you don't need to worry about adding heat to that. But when we're talking about airflow, you need to know that not every fan is created equal. And the amount of air that you're actually getting out of your bin fan is very dependent on how much static pressure that fan is being exposed to. Static pressure directly related to how much grain is in that bin. So you can see the chart on the left is actually 4 different 5 horsepower fans. They're all 5 horsepower. They're just different styles of fans. You can see the airflow is very different depending on the type of fan. An axial fan has excellent airflow at low pressure, but it really doesn't do well at high pressure at all. A centrifugal fan, especially a high-speed one, doesn't have as much airflow, but it can push through a whole lot more pressure. So depending on the type of bin or the type of fan you have, you can find this data from your fan manufacturers. Call them up and ask them for their fan chart. They'll give it to you, and you'll be able to see where your fan lands in terms of the airflow versus static pressure. Now, to figure out static pressure, the chart on the right gives you an idea of how much grain depth impacts it. So if you know roughly what your airflow is per bushel and how deep your grain is, you can estimate the static pressure from a chart like this. But it's even easier than that. You can just measure it. You can put a gauge on your bin. You can get gauges in inches of water. Those of you that aren't familiar with that measurement, 1 PSI is about 28 inches of water. So we're talking about very low pressures here. It doesn't take much pressure to overload a fan, I guess. But if you don't have a gauge like that, you can do it even easier. Just get a clear length of hose, fill it with water, stick one end into your bin plenum, and turn the fan on. And you'll see a difference in height appear if you bend that tube into a U shape. That height difference is literally your pressure in inches of water. That's how much your fan is having to work. So you can very easily measure the actual static pressure and then get an idea of your performance of your fan. You can also simulate it. There's a tool from Minnesota for those of you that like online tools as much as I do. This is a really neat one. You can put in your bin dimensions, the type of crop you're storing, and then you can choose your fan. And they have a fan database that has hundreds of fans in it. So you can probably find the one that you have or one very close to it. And then this tool will tell you roughly what airflow should you expect if you fill your bin to various depths of grain. Both in total airflow and airflow per bushel. So you can get an idea of the drying potential and the capacity of your fan. A couple other things to keep in mind when you are putting grain into a bin. Now, I know many of you are probably working with hopper bins. Coring a bin doesn't work as well with a hopper bin because you kind of get a mass flow situation going on. But if you do have a flat bottom bin, certainly you want to core that bin after you fill it. And that basically means taking out the central section of grain, You know, in a flat bottom bin, that's how grain kind of empties, funnel down, so you get that core pulling out through the middle first. Because most of the fines and small particles will collect in the center as that bin is filled. So by doing this, you get the bulk of that out. You make it a lot easier to get airflow through that grain consistently, because you're not going to have all those fines and weed seeds piling up in the center and blocking it up. Of course, if you have a hopper bin or a really tall silo and you can't do this, it's going to be more important that you get those fines out, and the larger chaff particles as well too. You're going to have to manage your combine a little bit better. I know Brent talked about that. You can adjust your fan settings, you can adjust your sieves to try and get that sample as clean as possible. Maybe you can even run your grain through a cleaner of some type before you put it in the bin to just try and get it as clean as possible. But it is really important to do that, because what we want in the bin is we want our grain to be very evenly distributed. We want the air pockets throughout that grain to be very even, because then we get the most consistent airflow. The other thing you want to do is level that bin out. Obviously, you fill a bin, you end up with a cone pointing up, and that's not, you know, the problem is then you get a grain depth in the center that's much deeper than your grain depth on the outside. And air takes the path of least resistance. So if you pump air through that grain, you're going to get much more air going up the outside than you do through the middle. If you level that grain out, you'll get a much more even air profile. And what happens if you don't do that is it's going to take a whole lot longer to dry or cool your grain, even up to, excuse me, almost twice as long if you fill that bin right full. So you certainly want to be careful of that. I mean, nobody wants to run their fans longer than they need to. Leveling out your bin, it is a bit of work. It's a good job for maybe a young farm hand, or maybe if you got some children or grandchildren with a little too much energy, you know, this can be a good activity, as long as it's done safely, and we'll talk about that as well. Now, as I mentioned, drying using natural air, using kind of the equilibrium method, it will take some time, a couple of weeks at least, probably. And certainly as you get later in the year and the weather gets a little cooler, a little wetter, it's going to take longer. Now, you can add heat to speed it up a bit, and by adding heat, essentially you're trying to dry out the air. You're not trying to warm it up so much as you're trying to dry it out and get that relative humidity where you want it. But it is important to have good airflow here, because the more airflow you have, the faster it'll go. The less airflow you have, the longer it will take. It's a bit of a complicated situation. I can't necessarily predict exactly what it's going to be for your own bin setup, because it's very dependent on airflow and local climate. But the timing, I mean, it will take you a couple of weeks probably to get it dry if it's decently wet. So be patient, watch for it. The grain dries in layers, so it'll dry from the bottom up. And if you are drying it, you'll see when it's almost dry, you'll see finally the grain at the top of the bin start to drop off in terms of moisture. Now, as I mentioned, you can add some heat to it, and there's a number of ways to do that. You can use a high temperature dryer. Something like a top dry system is a good option. You can usually dial those down fairly low temperature, and they're fairly gentle as high temperature dryers go. But there's other options too. If you have a dryer system available to you and you're comfortable running that at a low temperature, that can be a good option. You can also get portable heaters like the one pictured that can either connect to an existing bin fan, or you can buy them from a fan supplier that'll bolt right onto your existing fan. Again, it's going to depend on your heater capacity, your local climate, and how much air you're actually pumping through that grain as to how long it's going to take. Now, if you think about how much heat you need to add, think back to that equilibrium moisture chart. We want to hit that 60 to 70% humidity. So that means in most cases, we're trying to drop air a maximum of, say, 20 to 30% humidity, because you're probably at most starting at maybe 80 to 90% humidity, 95% on a really humid, foggy day. So that means you probably want a heater in the range of maximum, say 10 to 20,000 BTUs for every 1,000 CFM of fan airflow you have. So if you can get a heater with some control on it that lets you turn the heat up or down, this can be really helpful, because you can kind of dial it in. You can get humidity sensors that you can stick into your plenum and get a sense for what's going on there. You can even get humidity controllers that will bolt right onto your fan and turn that fan on or off depending on the humidity. So there's lots of ways to do it relatively simply. The other thing, again, that we want to be conscious of is aeration. Now, aeration assumes we have the grain dry or mostly dry already. So we still want to be running that fan on a regular basis to keep that grain in condition. Two reasons, really. Number one, once you fill the bin, you want to reduce the harvest heat. Even if that grain is already dry, you want to cool it down. And then secondly, you do want to be running another aeration cycle every time the outdoor temperature drops another 5 to 10 degrees. We do really want to try and keep that temperature as close as possible to the outside. And so there's lots of different fans you can get, lots of different airflow ranges. You probably want a little more if your grain's a little bit on the tough side, but yeah, you can do that. You can see again, you want to be running your fan kind of regularly throughout the fall season to cool that grain down. Then once you get into the winter and it's frozen down, you can just keep it there. Once you get into the spring, I know some guys like to keep the grain frozen. You can warm it up, especially if you're going to keep it into the summer and the following fall. You probably don't want to keep it frozen, but you do want to keep it as cool as possible. Now I know we're running a bit short on time here, so I think I'm just going to skip through to monitoring. And it is important to keep your eyes on your bin, check them regularly. Obviously, especially with seed beans, you want to make sure they're staying in good condition, and keep records of any inspections you make, because that lets you see how things have changed over time. Of course, there's technological tools you can use too. Most of us are familiar with bin cables, even if we don't have them. It's readily available, but there's some newer tech too, like this little 3D graphic you're seeing is actually a scanner system you can get that'll tell you the moisture of the various grain in your bin. You can also get CO2 sensors that'll detect spoilage from CO2 production. CO2 increases when grain starts to rot, and these systems will in some cases be able to predict spoilage faster than a cable system, even by a couple of weeks. And the advantage is they're a bit cheaper. So finally, safety. If you are having to go into a bin to clear it out, please do it very carefully. Never enter a bin when the auger's running. Always have somebody on the outside that can go for help, and always wear your safety equipment, not just a rope tied to your waist. I know it can be a pain to do this, but it's more of a pain if you get buried. And these are preventable accidents. So please be safe. In summary, seed soybeans can be harvested wet and dried safely. You can freeze them in winter without concern. It is safe to dry them even with some heat, as long as you're watching that relative humidity. And then you do want to be aerating your beans to keep them cool and dry in storage, even once they are dry. And there's tools out there that you can use. So thanks very much. I know this was a lot of information in a short time frame. I'll make sure Stacy gets a copy of this presentation and can share it with all of you. And my contact information's here. I'm happy to take questions at any time. I know we're short on time now, but please feel free to follow up with me afterwards, and I'd be happy to answer any questions you have.
Awesome. Thanks so much, James. You always have such good information, and I feel like it's just so timely to kind of get that as top of mind as we're going into a harvest like this. So thanks for going over that at Mach speed too, because we ran short on time there. So yeah, thank you all for joining this presentation here this morning, and thanks to all the presenters for such great information. If you guys have any questions or anything after this, feel free to text me. I'll make sure that all of their contact information is accessible to you guys, so you can reach out to them directly as well. But with that, I think we'll sign off here. So wish you guys all a safe and successful harvest, and to all the Manitoba guys that are on the call, you'll hear from me again, probably soon. So thank you.